Sorry. Hi, everyone. Thank you for being here. My name is Katherine Johnson. My thesis is a systematic review of existing enhanced rock weathering studies. That's ERW. The focus of this review is on atmospheric carbon dioxide removal. That's carbon dioxide removal is CDR due to enhanced rock weathering, which is basically mining, grinding, transporting, and spreading rock on a field. It's called enhanced because we grind the rock. Yes, it's working. Okay. We grind the rock to increase the surface sites and the access of water and carbon dioxide to weathering sites. This makes the process go much faster. Enhanced rock weathering combines water, rock, and CO2 to form weathered products. Rock prep requires at least 4 grinders, like this one on the left. On the right is a spreader. Many passes may be required to spread appropriate quantities of rock on a field. Enhanced rock weathering in red draws down carbon dioxide from the atmosphere and forms weathered products. Some of these are transported to the ocean. Ultimately, carbonates end up in terrestrial and marine sediments, where they become rock and are sequestered for geologic timescales. Enhanced rock weathering addresses 6 of the 17 United Nations sustainability goals. It reduces atmospheric carbon dioxide, increases food yield, returns our soils and oceans to health, reduces our dependence on fertilizers and fossil fuels. These tasks are important for continued existence on Earth for humans and many other species. We'll cover accomplishments of this review, CDR influencers, and actionable items. My review also analyzed and discovered findings from the list on the right. I'm interested in regenerative ag in association with ERW. I'm happy to discuss any of these topics after this presentation. This review was a massive data collection from 16 studies and over a decade of research. Inclusion criteria were physical studies, no simulations, studies with planted, actively growing crops, not plant colonization, studies which reported CDR, and plants were food crops, not construction materials, as are some of the tree forests of North America and bamboo forests of China, even though they were planted. I'm presenting a subset of my findings today. I determined which factors drew down the highest amount of carbon dioxide. The efficiency was stated or calculated in tons of CO2 per hectare per year divided by the rock concentration per hectare per year. Efficiency is how effectively that factor used the rock. I created a strength assessment score to describe robustness of a study based on study design. An example, a 3-year-old study across 32 sites and 4 climatic zones in China with 3 replicates would earn a high score. Based on ranges of CDR values, I determined sweet spots for optimal conditions. Now I'm going to show you the results of this review. This is a range diagram for CDR and efficiency values across the studies I reviewed. I'll show you multiple figures of CDR and efficiency ranges from published papers. For example, on panel A on the top, this is a range diagram showing ranges of carbon dioxide removal, CDR, by rock type. In contrast, panel B on the bottom shows efficiency ranges for the same studies. The pink and violet rows on these graphs represent wollastonite and wollastonite heavy volcanic ash. You can see the highest ranges and optimal choices for CDR and efficiency are both wollastonite. I want to plant a seed about glacial rock flower in turquoise. It doesn't do well for CDR or efficiency, and I will talk about that towards the end of this presentation. Here's a range diagram showing concentration influences on CDR. Rock concentration is tons of rock per hectare per year. As you can see here, CDR increases as we add more rock. However, these increases become relatively small for massive additions of rock, up to 400 tons per hectare per year. To illustrate this, studies which used 40% of the maximum rock drew down 71% of the maximum CDR in the studies reviewed. 2.5 times that amount of rock only increases the CDR by an additional 29%. The reason is likely the compaction of the rock due to many heavy passes of a spreader. Optimal rock powder concentrations are likely between 80 and 160 metric tons per hectare per year. When efficiency is considered, under 10 tons of rock performed well also. So we are likely putting too much rock on our fields. Less rock and more fields are indicated. Particle surface area. Top is CDR and the bottom panel is efficiency. As we grind the rock smaller, we increase the surface size, the surface area, really. We can see diminishing returns in the particle surface area past 3.5 meters squared per gram. Drilling into the data, the sweet spot centers around 2 square meters per gram. And for visualization of this, imagine a rock-sized dice, about a gram, and we're going to slice it really, really thinly, and we're going to put it on 2 square meters, which is 1.41 times 1.41, right? Spread it around that whole square. And that is going to cover a lot more than the original 6 faces of that dice. Okay, plants and CDR. The top panel, individual plants, and the bottom panel is a summary of plant classifications, both CDR. Panel A, sorghum, a cereal grain in tan, and miscanthus, a biofuel in orange, and soybeans in deep purple performed very well for CDR, as did alfalfa in violet. But alfalfa used a lot of rock, huge concentration of rock. Classification groups refer to pathways that plants use to photosynthesize. So in panel B, nitrogen fixers, both C3 and C4 as groups drew down the highest amount of carbon dioxide. Aha. Plants and efficiency, these are both efficiencies. The top is individual plants and the bottom is a plant summary by group, both efficiencies. The best performers for CDR are not always those with the top CDR amounts. Remember, efficiency is efficiency is CDR divided by rock concentration. The highest in efficiency is the best use of the rock. Leafy green vegetables were the most efficient plants in these studies, in forest green on the far right. These plants drew down the most carbon dioxide per unit of rock. These results were driven with under 5 tons of rock per hectare per year. In the bottom panel, summary, C3 and C4 groups were respectively the next 2 most efficient categories. The Köppen-Geiger climate zone classification is based on vegetation and is much more detailed than NOAA's 5-tier classification. The colors on this map will match the next range diagram. The global extent of these studies, just very quickly, are in black circles. So 3 in the US, 2 in Canada, 2 in Europe, 2 huge swaths of China, and 1 in Malaysia. Climatic zones. CDR on the top, efficiency on the bottom. Panel A, which the climate zones which drew down the most CO2 were 2 different types of humid continental zones, DFA light blue and DFB dark blue, representing China, Canada, and the United States. The monsoon and humid continental zone of China, DWA, violet, also showed a high efficiency in the bottom panel there. Now we're going to talk about upfront costs. Rock prep is carbon dioxide producing due to fossil fuel-based machinery. At least 4 stages of crushing rock are required to reduce rock to powder. CO2 emissions are functions of distance to the quarry, to the field, and the size to which the rock is ground. These are massive machines. Many of these rock hauling trucks, like the one circled there in the middle, have humans tall wheels. They're huge. What is net CDR? Upfront emissions must be subtracted from the total amount of CO2 drawn down to get a net result. For example, remember global Greenland rock flower seed that I had planted earlier? The rock was dredged from the bottom of a water source, and it was close to the field. So this is great for the upfront cost, no grinding, hardly any transport, but the powder proved to be weathering resistant, which means it didn't pull down much CDR, or didn't pull down much carbon dioxide. I want you all to remember, enhanced rock weathering works. It works across all variability in all studies all the time for billions of years. Hard stop. It works. And sometimes it works even better than others, based on a number of factors. We are likely putting too much rock on our fields. We have a target for optimum surface area. We all don't have to eat leafy green vegetables. It works with lots of different combinations of plants. And the study strength scores reinforce these findings as generalizable. We have some to-dos for future work. Studies need to report net carbon dioxide removal. Also, more studies are needed on regenerative agriculture and ERW together. I found only one study compared RA to CA, and that's conventional ag. And they did this based on a conventional till versus a reduced till, and there just wasn't much difference in the carbon for those parts of the experiment. These are quotes from David Bierling, a lead researcher in the enhanced rock weathering field. It's up to us. China, India, Brazil, and the US are in the optimal climate zones. So it's up to us to draw down as much carbon dioxide as we can, as fast as we can. The US is a major contributor to atmospheric carbon dioxide and needs to get to net zero quickly. There is no, as yet, political desire to do this and very low public awareness. What can we do? Farmers need government subsidies to run their farms annually. The government restricts our choices, or farmers' choices, on what they can and cannot do with their crops when they take that money. So the Farm Bill renews in September. We live in a democracy. We can write our Congress people and tell them we want friendly legislation for ERW. And that's so important. Talk to your friends, talk to your neighbors, wear a t-shirt, do the social media thing, whatever you need to do to spread the word on spreading rock. I want to thank all of you for being a wonderful audience. I want to thank especially my thoughtful and patient reader, Carrie Leroy, and our resident miracle worker, Avery Azar, and all my friends and family and supporters and my cohort. Thank you so much. And I am ready for your questions.